In this video, we are going to learn about how the producer-consumer problem is solved using the semaphore variables. So in this program, we are making use of some semaphore concept to implement the producer-consumer problem. As we all know, producer will be producing the items and consumer will be consuming those items that the producer produced. This is the procedure. So it can be implemented using a shared memory concept, and that shared memory, it can be either a bounded one or a unbounded one. If it is a bounded means, producer will be producing only the required number of elements, and once the buffer is it shows whether the buffer is full or not in case of a bounded buffer. And once the buffer is full, it waits and allows the consumer to consume all the item that is produced by the producer. So here critical section will be there, that is shared by the producer and the consumer. That is the item that is given for display, or that is stored, or that is given by the producer, and the consumer, what is the item that is taken by the consumer. So these item will be shared by both producer and the consumer and will be treated as the critical section area. Then in case of unbounded buffer means, producer, it will be producing the items infinitely. Any number of items it can produce with no bound or with no limit, and the consumer parallelly it will be consuming those items from the producer, from that shared area. Then once the consumer, if it consumes the item, the buffer will be the element will be removed from the buffer. So again, before producer producing the item, if consumer tries to consume the item, then it should show that the buffer is empty in case of unbounded. Similar is the case with bounded also. After producer producing all the items, when consumer consumes those items, what happens? These elements will be removed from the buffer, which means that there are available slots. There are some slots that is available for the producer to produce. So this concept, how it is implemented in this program, we are going to see. So here we are making use of three variables, mutex, full and empty. So these can be considered as the semaphore variables. So semaphore variables are those variables in which the operations like wait and signal can be applied. So wait operation, what it does, it reduces the value of the semaphore by 1. It will be decrementing the value, and in case of signal, it will be incrementing the value by 1. So that is the case of wait and signal, decrementing and incrementing. So this wait and signal, to which all variables it is being applied, those variables will be called as semaphore variables. So in our program, we have used mutex, full and empty for this wait and signal, to perform the wait and signal operations. So we can say that this mutex, full and empty are the semaphore variables, in which mutex will be acting as a binary semaphore variable, in which it will be taking the value either 0 or 1. That we can see how it is taking the value, and when it becomes a 0, and when 0 and 1 value it happens to assign. Then full and empty, it will be taking some value, in which full it monitors the number of elements that the producer produced, and empty, it helps in checking how many slots are available for the producer to produce. Okay, so this is a case with the semaphore variables. Then once we need to initialize we need to apply those operations to those semaphore variables, so that it won't rise into any form of deadlock or synchronization. Okay, making use of these semaphore variables, it helps in implementing the synchronization in the process. Okay, synchronization between both producer and consumer. Though synchronization is possible making use of the semaphore variables. That you can see if you comment any of this signal function, then the entire program it will be giving an error display. It will not be giving a correct display. It will be giving some form of error in display. So starting with so we have seen wait and signal. Then once producer function, when it is being encountered. So if mutex is equal to 1 and empty not equal to 0, producer function is called. So empty first it is assigned as 3, which means that there are 3 slots available for the producer to produce its items. In case of bounded buffer, it will be checking like that. Okay. In case of unbounded buffer, this case is not used. Simply what the elements that is being inserted, it will be given for display. So when if mutex is equal to 1, that is mutex first it is initialized to as 1, and when it enters into any producer or consumer, when it enters into any one of this process, it gives a operation, it performs an operation like wait of mutex, which means wait of mutex means it will be decrementing the value of mutex by 1. So the result of mutex will be equal to 0. So once it enters into the producer function, mutex value will be equal to 0. Full will be equal to signal of full. Signal means increment the value. Full is first initialized to as 0. Signal of full means it will become 1. Then wait of empty means currently empty is equal to 3. So wait is performing decrement operation. So now empty will be equal to 2, which means producer can produce 2 more elements, or 2 slots are available for the producer to produce the items. So this X indicates the data part. That is, you can include, instead of this X, you can include some array or insert some element into that array. So here an X is used, which is used for incrementing the values. That is the critical section part. And printf produces the item, that is X. Then mutex is equal to after producing the item required, mutex, it signals the mutex, that is increments the value of mutex to 1. And in case of unbounded buffer, it calls for the consumer function. Consumer, again it gives a wait, that is decrements the value of mutex. So when here signal is being done means increments the value, in which the mutex value will become 1. Wait of mutex, again consumer makes the mutex value as 0. Then wait of full. So full, when one element is entered, this full becomes 1. Wait of full means it will be decremented, meaning the element that is being produced by the producer is going to be consumed by the consumer, or it will be consumed. Okay, so the consumer consumes the element. And signal of empty, which means increment the value of empty. So when one element is entered in by the producer, wait of empty is decremented by 1, resulting in 2 slots that is available. Then consumer, when it consumes the element given by the producer, consumer signals empty, which means increment the value of empty, which means now there is available 3 slots. The producer can produce the items for these 3 slots. Then consumer consumes the item, and then what it does, it increments the value of mutex using the signal operation. So this is the case with the unbounded buffer. So once you run this program, you will be getting the result like this. In case of unbounded buffer, when you run the program, you will be getting the result like first you will be entering the producer, that is some value. Okay, it takes time, so okay, for time being we can continue with the next that is a bounded case, in which for bounded case what you have to do is we need to include this consumer function can be removed from the producer part. Okay, this consumer function need not necessary. First producer will be producing all the elements, and then consumer, this can also be commented. This one can be commented. Okay, this can be commented, and uncomment this one. That is which all items are being produced. If n elements are produced by the item, means that n elements will be stored. X will be having that n elements, and the consumer can display those elements in the order in which producer is produced. And here full and empty, that is wait and signal operation for full and empty variables need to be included within this while loop. Okay, not outside the loop. It need to be included within the while loop, because a sequence of elements will be consumed by the consumer. In previous case, one at a time it was consumed. So the function is not included inside this loop. The loop itself was not used. In this case, the loop is used in which a sequence of items will be consumed by the consumer. So in such a case, the full and wait and signal operation for the full and empty variables need to be included inside the while loop. After performing the operation, you need to give the signal of mutex, that is increment the value of mutex. So this is how you will be able to perform the producer consumer problem. And when the buffer is full and buffer is empty, how it is shown. If empty is equal to 0, then buffer will be full, and full if it is equal to 0, buffer will be treated as empty. For mutex is equal to 1 and empty equal to 0, mostly this buffer will be shown as full if empty is equal to 0. Also, if the mutex signal, if the signal and wait operation is not properly given for producer and consumer, then in that case also the buffer will be shown as full. Okay, which will be an error case. Okay, so this is how you will be implementing the producer consumer problem.